Welcome to SL Pharma YouTube channel. Today we are going to discuss about wet granulation. First we will see what is the granulation. Granulation is the size enlargement process in which primary powder particles are made to adhere to form larger, multi-particle entities called granules. Granulation, a technique of particle enlargement by agglomeration, is one of the most significant unit operations in the production of pharmaceutical dosage forms, mostly tablets and capsules. During the granulation process, small fine or coarse particles are converted into large agglomerates called granules. Granules are prepared by two methods, dry or wet granulation. Dry granulation includes dry mixing, slug-to-slug and roller compaction processes. Wet granulation includes aqueous granulation and non-aqueous granulation. Then we will see what are the main difference between dry granulation and wet granulation. Dry granulation is the process of forming granules without using any liquid solution, and wet granulation is the process of forming granules by adding a granulating liquid. Dry granulation involves the direct compression of a finely ground powder, and wet granulation involves mixing the powder with a granulating fluid, followed by forcing through a sieve to make tablets. Basically, dry granulation requires finely powdered compound in tablet pressers or roll compactors, and wet granulation requires powder particles, a granulating fluid and a sieve. Dry granulation required when producing tablets from highly moisture and heat-sensitive compound, and wet granulation required to avoid the destruction of active components in the powder. Dry granulation can be achieved through roller compaction or slugging. Dry powder is passed through a roll compactor, which is then granulated to uniform particle size and used to form different textures. Granules created by this method are porous and highly compressible and allow for fast disintegration and modification of release time. This process is excellent for moisture-sensitive drugs. For molecules sensitive to external factors like temperature, moisture can be generated by the dry mixing process. Manufacturers can, if needed, select molecules with specified particle size and directly compressible grade of excipients. Wet granulation has seen many technical and technological innovations as compared to dry granulation. Molecules that need wet granulation are those not suited for dry granulation process: high dose, poor flow, low in bulk density, without binding properties. Wet granulation is a widely used technique that produces granules via wet massing of the active pharma ingredient, API, and granulation liquid with or without a binder. Wet granulation is carried out in two ways. One method is to moisten the powder or powder mixture and pass it through a screen of the mesh size needed to produce granules in the desired size using dry heat. The second type used a fluid bed processor in which particles are placed and vigorously dispersed and suspended while liquid excipient is sprayed onto the particles and dried. Depending on molecule sensitivity, aqueous, water, or non-aqueous, organic, solvents are used for the granulation process. Aqueous processes are considered safer and cost-effective. Then we will see what are the reasons for the granulation process. Granulation is carried out for various reasons, such as to increase the flow property, to increase the apparent density, to change the particle size distribution, uniform dispersion of active ingredient, to improve the compressibility and consolidation. Now that we know what granulation is, the various granulation methods, and why granulation is important in the pharmaceutical industry. In this video, I'm going to focus solely on wet granulation. Wet granulation is a common method for preparing pharmaceutical tablets and other solid dosage forms. Let's see step-by-step overview of the wet granulation process. First step is weighing. Gather and measure the active pharmaceutical ingredient, API, excipients, and binders according to the formulation. Then material sifting, also known as sieving or screening, is a process of separating particles or solids of different sizes by passing them through a sieve or mesh. Sifting is used to particle size classification, particle size reduction, removal of impurities, aeration, homogenization. Then mix these ingredients in a dry blender or RNG to achieve uniform distribution. Then prepare a binder solution, typically using water or a solvent, depending on the formulation. The binder helps bind the powders together. Then add binder to dry mixed blend that is in the high shear or low shear mixer. Then gradually add the binder solution to the mixed powders while mixing. This process can be done in a high shear or low shear mixer. Continue to mix until the powders form into small, wet agglomerates. Then pass the wet granules through a screen or sieve to break them into smaller, more uniform granules. Then dry the granules to remove moisture. This can be done in drying ovens or fluidized bed dryers. After drying, sift and mill the granules using multi-mill and Vibro sifter to get uniform particle size. A Vibro sifter, also known as a Vibro screen or vibrating screen, is a versatile machine used for the separation, grading, and sizing of powders and granular materials. It operates by imparting a vibratory motion to the screening surface, which helps to separate and classify particles based on size. There are several steps to operate Vibro shifters. First, feeding. The material to be screened is loaded into the feed hopper of the Vibro sifter. This material can be in the form of powders, granules, or other particulate substances. Then vibration. The Vibro sifter is equipped with an electric motor and an eccentric weight assembly. When the machine is turned on, the motor generates vibrations in the screening surface, which is usually a mesh or sieve. Then screening. The vibratory motion of the machine causes the material to move and stratify on the screen. Particles smaller than the openings in the mesh pass through the screen, while larger particles are retained. Then separation. Depending on the specific application, the Vibro sifter can be used to separate oversized or undersized particles, classify particles based on size, or perform other separation tasks. Different mesh sizes can be used to achieve the desired separation. Then collection. The separated material is collected in separate outlets or containers. Oversized particles may be discharged from one outlet, while the acceptable product is collected from another. Then repeat or recycle. If necessary, the separated material can be recycled through the Vibro sifter for further screening or separation. Cleaning and maintenance. After use, the machine needs to be cleaned and maintained to ensure it continues to operate efficiently. This involves removing any residual material and inspecting the screen for damage or wear. Mesh sizes refer to the number of openings or apertures per linear inch in a screen or sieve used for the purpose of separating, grading, and sizing particulate materials. Mesh size is a critical parameter that determines the particle size range and the flow rate of materials through the screen. According to the US standard, mesh is a system where the number of openings or wires per inch is used to denote the mesh size. For example, a mesh size of 20 means there are 20 openings per linear inch. A high shear mixer granulator is a complex piece of pharmaceutical processing equipment that consists of several components, each serving a specific purpose in the granulation process. We will see main components of the high shear. Main mixing bowl or chamber. This is the central vessel where the granulation process occurs. It's typically made of stainless steel and is designed to hold the dry powders, allow for wet granulation, and provide space for the mixing and granulation blades. Impellers or mixing blades, these are agitators located within the mixing bowl. They are responsible for mixing the dry powders, breaking down agglomerates, and creating the wet granules. There can be different types of impellers, such as high-speed chopper blades and main mixing blades. Chopper blades. Chopper blades are high-speed cutting blades or knives that are often used in high-shear mixers to further break down and refine the granules, ensuring uniformity in particle size and consistency. Control panel. The control panel contains the machine's control interface, where operators can set and adjust process parameters such as mixing speed, binder flow rate, and temperature. A high-shear mixer granulator is a pharmaceutical processing machine used for mixing and granulating various ingredients to form granules, which are then used to produce tablets or other solid dosage forms. The process involves blending dry powders and adding a liquid binder to form a wet mass, which is subsequently dried and processed into granules. First, loading ingredients. The process begins by accurately measuring and loading the dry powder ingredients into the high-shear mixer granulator. These ingredients typically include the API, excipients, and other additives. Secondly, mixing dry ingredients. The dry ingredients are initially mixed together in the machine. The mixing blades or impellers within the granulator work to achieve a uniform blend of the powders. Thirdly, wet mass formation. A liquid binder, usually a solution of water or another appropriate solvent, is added to the dry powder mixture. The binder is sprayed onto the powders as they are continuously mixed. The combination of the liquid and mechanical agitation causes the powders to form wet granules. The binder helps agglomerate the particles and create a homogeneous, moist mass. Fourthly, granulation. The granulation process continues with intense mechanical agitation provided by the high-shear mixer. This agitation helps break down any lumps and ensures uniform distribution of the binder throughout the mixture. The formed granules grow in size and achieve the desired size and consistency. Wet granulation is indeed a process that involves several key steps, including dry mixing, wet mixing, and particle size enlargement. In the initial stage of wet granulation, dry powders are mixed together. These powders typically consist of the active pharmaceutical ingredient, API, excipients, and other additives. The dry mixing step aims to achieve a uniform distribution of all the ingredients in the mixture. This is important for ensuring consistent product quality. Wet mixing. After the dry mixing, a liquid binder is introduced into the mixture. The binder is usually a solution containing water or another suitable solvent. The wet mixing phase involves adding the binder to the dry powder mixture while simultaneously agitating or blending the materials. The binder causes the powders to agglomerate and form a wet mass or wet granules. They form wet granules that are larger and more cohesive than the individual powder particles. The wet granules are typically softer and more easily compressible than the dry powders, which makes them suitable for downstream processes such as tablet compression. Wet granules. Residual liquid after granules have been dried gives strength to final granules. Thin immobile layers may also be formed by highly viscous solutions of adhesives, and so the bond strength will be greater than that produced by the mobile films. For example, starch mucilage. Bond formation. Bonds must be formed between powder particles to form granules. They adhere, and these bonds must be sufficiently strong to prevent breakdown of the granule to powder in subsequent handling operations. There are three main types of bonds involved in the formation of granules: adhesion and cohesion forces in immobile films, interfacial forces in mobile liquid films, and attractive forces between solid particles. A fluid bed dryer is a widely used industrial equipment for drying or cooling solid particles in a fluidized bed of air or gas. It consists of several key components to facilitate the drying process. We will see main components of the FBD. Product container or bed. This is the main chamber where the solid particles to be dried or cooled are placed. The container is designed to allow for even distribution and fluidization of the particles by introducing a flow of hot air or gas from the bottom. It's typically made of stainless steel and can vary in size based on the application. Air inlet. The inlet is the point where hot air or gas is introduced into the fluid bed dryer. It is strategically located at the base of the product container to create the fluidized bed by lifting and suspending the solid particles in the airstream. Air handling system. This includes a blower or fan, heating elements, and temperature control systems to supply the hot air or gas at the desired temperature and flow rate. It is responsible for creating the fluidized bed and controlling the drying process. Filter bag or filter housing. A filter system is often incorporated to separate the solid particles from the exhaust air or gas. This ensures that fine particles are not carried away and lost during the drying process. Outlet or discharge port. This is where the dried or cooled particles exit the fluid bed dryer once the process is complete. It can include mechanisms like rotary valves or slide gates for controlled discharge. Product inlet-outlet ports. These are openings in the product container that allow for the introduction of materials to be dried and the removal of dried materials. Fluidization in a fluid bed dryer is a key principle that allows for the efficient drying or cooling of solid particles. Fluidization involves suspending and agitating solid particles within a bed of air or gas in such a way that they behave like a fluid. This process ensures uniform heat and mass transfer, promoting efficient drying and cooling. A multi-mill is a versatile pharmaceutical and industrial processing machine designed for size reduction, granulation, and material handling. It is commonly used for applications such as milling, granulation, and pulverization of powders and granules. In a multi-mill, screens play a crucial role in controlling the particle size of the milled or granulated material. Different screens with varying hole sizes can be used to achieve the desired particle size distribution. Choosing the appropriate screen size is crucial for achieving the desired particle size and quality of the milled or granulated material. Diameter of the opening in millimeter called screen size. This is the overall process of the granulation. Now that you know what granulation is, why granulation is done in the pharmaceutical industry, and how wet granulation is performed. If you want to know about pharmaceutical manufacturing things, please subscribe my channel and hit the bell button. So see you in next video.